Hello and welcome to the channel Understanding Concepts of Physics. Today we are here to again continue with our topic for graphical representation of linear simple harmonic motion for a particle beginning from mean position. This topic has been continued since past two videos, and this is the third and the last video for this particular topic. From next video onwards we will be discussing the B part, that is the particle beginning from extreme position. So this is that extreme position thing, but we are not going to discuss regarding extreme position today in this video. So let's see, the conclusion for the graph is what? All the graphs repeat after a phase of 2 pi radians. Now before we go to the phase, we'll have to plot phase here. So if you see the table, phase is this part. So instead of t, where I have plotted t, I'll have to convert that graph to omega t, that is phase. So what we are going to just multiply omega with t. So if I multiply this by omega and this by omega and this by omega, then I'll find out that my x-axis, which was earlier time, now it will become phase. So I'll just change that. So now this is omega, this is omega, the velocity time graph, and this is your acceleration time graph, omega t. So my coordinates will also change. Now the coordinates will become now for 0 it is 0. If you see, for 0 it is 0, that is 0 time ke liye you have phase as 0. Then for t by 4 it is pi by 2, then t by 2 is pi, 3t by 4 becomes 3 pi by 2, t becomes 2 pi, and 5t by 4 becomes 5 pi by 2. Or you can just go like this: 0 pi by 2, 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, and 5 pi by 2. So we'll just write this on the x-axis. It would look something like this. It would look something like this. I'll just have to erase this first. Okay, so let's see how it works. Okay, now the first is 0, and then you have pi by 2, then you have pi, then you have 3 pi by 2, and then we have something called as 2 pi and 5 pi by 2. So just I have plotted time. Instead of time, I have plotted omega t, that is the phase. So the graph will look same. So if you see, the graph has been repeating after itself after 2 pi radians. So this is also repeating after 2 pi radians, and this is acceleration is also repeating after 2 pi radians. Like this was starting and going upwards toward positive side, and here also it is going upward toward the positive side. That means the graph has repeated after 2 pi radians. Same, the graph was at maximum at 0, and here is also it is maximum at 2 pi radians. So this is the same axis which is going till down, and then the graph was going downwards, and the graph was going downwards, so it is repeated after 2 pi radians. So this is 0 and this is 2 pi radians. So that's what the first conclusion is: all graphs repeat after a phase of 2 pi radians. Then xt graph and at graphs, that means the displacement time graph and the acceleration time graph, are sine curves. So how do you identify sine curves? The sine curves are curves which start from 0. So this curve starts from 0, this curve starts from 0, but the velocity graph starts from a maximum. So if it starts from maximum, it is a cosine curve, and the graphs which start from 0 are called as sine curves. Now if you are not able to identify that way, if you are not so mathematically inclined, then look out for an equation: sine curve, sine curve. This is a cosine curve. So displacement and acceleration is basically sine curves, and velocity is a cos curve. So that is mentioned in the second and the third point. Now this is the most important point, that is the phase difference between displacement and velocity is pi by 2, velocity acceleration is pi by 2, and displacement acceleration is pi. Now how do you do this? So for that, what we are going to do is we are going to cut the velocity time graph, and we are going to paste it on the displacement time graph. So if you see this orange curve, I have already cut that graph, and I am going to paste that on the displacement time graph. So it would look something like this. This is the same graph. If you can see, this is the same velocity time graph. Now I'm going to paste this on the velocity time graph, so it would somewhat look like this. Now you should note that when you are doing, you are not supposed to paste it while you are writing in your exams or something. This is just for your explanation. Now if you see, the yellow curve is the displacement curve and the orange curve is the velocity curve. So this is your velocity curve, this is your displacement curve. Now how do you find out the phase difference from a graph? So finding out the phase difference from a graph is pretty easy. You just have to find the peak to peak difference. Peak to peak difference. So peak of one graph to the peak of another graph. So if you see, the peak of yellow graph is at pi by 2. So the peak of yellow graph is at pi by 2 minus. Now the peak of orange graph comes at 0. So the peak of orange graph comes at 0. So pi by 2 minus 0, you get pi by 2 radians. So the phase difference between these two, that is the yellow graph and the orange graph, is pi by 2 radians. That means the phase difference between the displacement and velocity is pi by 2. That's what our next point is. Displacement and velocity, you have a phase difference of pi by 2 radians. Now let's see for another combination. We'll find out between the velocity and acceleration. So if I want to find out the velocity and acceleration, I'll have to paste the this graph. So I have this velocity graph and I'm going to now cut the velocity graph and paste it on the acceleration graph. So this is where it is. Okay, now again the axis remains same, so you need to refer to this pi by 2 pi, 3 pi by 2, 2 pi and 5 pi by 2. Now if you check this out, the orange graph is your velocity graph, and the green graph is your acceleration graph. Now the orange graph has a peak at this point and the green graph has a peak at this point. So if I just see, orange graph has a peak at 2 pi radians, so 2 pi radians, and the green graph has a peak at 3 pi by 2 radians, 3 pi by 2, so minus 3 pi by 2. So 2 pi minus 3 pi by 2, this would be like 4 pi minus 3 pi upon 2, which is equal to pi by 2. That means for velocity and acceleration it is also pi by 2. So I get as for velocity, acceleration is also pi by 2. Now we will find out the displacement and acceleration, which is the last combination. So for that, either I have to paste the acceleration curve on the displacement curve or the displacement curve on the acceleration curve. So I'll paste the acceleration graph, which is the green graph, onto our graph of displacement. So this is what it looks. So now keep in mind that yellow graph is your displacement curve and the green graph is your acceleration graph. So this is your displacement. Now let's find out the peak to peak difference. So if you see, the peak of yellow graph is at pi by 2 and the green graph has a peak at 3 pi by 2. So 3 pi by 2, which is the green graphs, and that is the acceleration, minus this is at pi by 2. So 3 pi by 2 minus pi by 2 will give me 2 pi by 2, and 2 pi by 2 is nothing but pi radians. So what I got is, I have got displacement acceleration has a phase difference of pi radian. These can be asked in MCQs or somewhere, where you just have to remember that displacement velocity and acceleration. So displacement velocity pi by 2, displacement velocity pi by 2, velocity acceleration pi by 2, but displacement and acceleration, it is pi. So just remember this. Okay, if you are finding out for displacement velocity, it is pi by 2. For velocity acceleration, it is pi by 2. But if you are doing it for displacement and acceleration, it is pi radians. Now you are not supposed to draw this overlapping curves. Just do not draw the overlapping curves. You just have to ignore the overlapping part. So I'll just remove every other aspects over here. You're not supposed to draw the omega t axis as well. You're not supposed to draw the overlapping curve the way I made it. you can just go back to the timestamp and just check for your confirmation, or you can just check it for your understanding. But you are not supposed to draw the overlapping curves. Overlapping curves should not be drawn. You are supposed to draw only this part. Now, in the tomorrow's video, what we are going to do is we are going to start with for particle beginning from extreme position. And yes, definitely this video will not be so long. For mean position, I have explained that thing is in a pretty much detailed manner. But for extreme position, we'll be doing it pretty fast, and I have just prepared the format, everything, and even the conclusions will remain almost same. So in case you have not subscribed the channel, you can subscribe the channel and keep watching the videos from the playlist again and again. Prepare your lectures hard, prepare your topics nicely, and every day if you keep on doing one article, things will be definitely a lot when you see at the end of some days. Thank you so much for watching. Subscribe the channel in case you have not done so. Thank you so much. Have a nice day. Bye.